Integration. What is it? Correct. It's the opposite of a derivative. Okay, like the log, undos and e. Yeah, log, opposite of e. Antiderivative, opposite of derivative. Integral, opposite of derivative. So if you see antiderivative, it's the same as integration. Okay? It means the same thing. There's lots of applications of this, hence why we do it. We're not just doing it for fun, although it is quite interesting. Okay, so anyone know the applications? Maybe you've heard from an older sibling. Yeah, a very common application is the area under a curve. If you have the velocity, you can use integration to find the displacement for that velocity. Okay? If you have the acceleration, you can find the velocity using that acceleration, using integrals. Okay? The third application, volume. So you can use the volume or find the volume of 3D shapes. I'm going with the half pipe today. Don't know what a half pipe is? It's a thing you can skateboard on.
It's half pipe.
Congratulations. Okay, and you want to know how much concrete you need. You're sick of the wooden structure, you want to turn it into a concrete structure. So you need the area under the curve. You can use integrals to find the area under the curve. Right? And then you multiply it by the depth of your half pipe, and you get the volume of the half pipe. We're going to get to definite integrals later when we do area under a curve. We're not going to do area under a curve today. We're just going to do the real basics of integration. So where did this come from? There is this guy. Have you heard of him? Leibniz, and Newton. So integrals were actually found before these guys, but apparently they found that integrals were the opposite of derivatives. So they connected the dots. And we have special notation which comes from Leibniz. He came up with the integral sign that looks like this. Okay, it's like an S kind of extended out a bit. He's saying it's a giant S to represent S, the letter S, which is the first letter of sum, S-U-M. Alright, if you're not sure what I'm talking about when I say the S stands for sum, so integration, like I've said numerous times now, is finding the area under a curve. You get all these rectangles, add them all together. I know, they're terrible rectangles. Add them all together, and you get an approximate area under the curve. So integration, also called antiderivatives. Let me go back to derivatives first. Okay, so if you have these three functions, y equals 2x plus 1, y equals 2x minus 5, or y equals 2x, what is the derivative of these three functions? The derivatives of these three are 2. Now, we want to go back the other way for an antiderivative, so we're going to do the opposite. Instead of minusing 1 from the power, we're going to add 1. And instead of bringing the power out the front, we're going to divide by the power. The antiderivative of 2 would become 2x. And we add this plus c at the end because we don't know what the constant is. You can see in the first function, the constant is 1. In the second function, the constant is -5. And the third is 0. So we just don't know what the constant is. That's why you add the plus c. So like I said, the formal notation, we have this big S symbol. Okay, we have the S symbol, and then the function, like before it could be 2x, and then we have dx at the end. So like I said, you add 1 to the power. This is the general rule just for basic functions, not trig functions, not exponentials, just the basic, x to the power of something. Okay, so let's have a look at this one. So what did I say we have to do? So we're not doing antiderivative yet. I want you to refresh your memory about derivative. So the general derivative rule is, what do we do to the power? Times the coefficient by the power, and you minus 1 from the power. What happens to the 3? It disappears because there's no x. So it's currently x to the power of 0. Okay, so it disappears. So that's derivatives. So that was the derivative of the function. Or that is the derivative of the function. Minus 1 from the power, bring it out the front. What is the antiderivative of 12x? You do the opposite now. Instead of minusing 1, you... So we're going to integrate. This is the notation. We're going to integrate 12x. So we're going to add 1 to the power. So 1 plus 1 divided by 1 plus 1. But we also need to do plus c. Plus c. Making it a little bit neater, 12 divided by 2. So there's the antiderivative of 12x. We don't know what the constant is because we weren't given a constant. In terms of we weren't given any information to help us find the constant. Although the original constant was 3, we don't know that if we're just anti-deriving. So you should have written this down. The dx at the end is saying we're finding the integral in terms of x. So if I want you to find the integral in terms of a or the integral in terms of y. None of these things contain y, so you would just add y to each of them. Because you're just adding 1 to the power of that. But we're not doing it in terms of y for this question, we're doing it in terms of the little change of x. So you added 1 to the power. We don't have to write it like this every time. You can just do it in your head, by the way. Like that. So I added 1 to the power divided by that new power. I'm going to add 1 to the power. It becomes x squared divided by 2. And we always need to write plus c. So everyone's okay with that? So let's talk about the little tips and tricks. So if you have the integral of the sum of two functions, so that was literally the example I just did, example 2. It had 9x to the negative 4 as one function plus 4x as the second function. So you do the integral of the first function plus the integral of the second. Does that make sense? No. You just write it like this. That's all you have to do. So see how it's integrated that, and it's integrated that. It's not somehow integrating them together. You integrate each function separated by a plus separately. Yeah? Function. Yeah, each term is its own function. There's this other really, really useful trick. Please remember this. If you have a function with a constant out the front, you can bring that constant out the front. So you can bring it out the front just so you can focus on the rest of the function. Okay? See how it's brought the 6 out the front and then it's just integrated x. A really useful thing is if you're doing something like this. Pi is a constant, so you can bring it out the front. And now just integrate x squared. If we have the gradient and we want the original function, we need to, the opposite, we need to integrate to find the function. We have the gradient, we integrate the gradient, we find the function. So we're going to find the equation. If we integrate the gradient, we find the equation. Yep. So if there's ever a constant and you're integrating a constant, it's like, so this one is the same as writing 2x to the power of 0. Because anything to the power of 0 is 1. So you add 1 to the power, divide by the new power. So if you integrate this, it becomes add 1 to the power, divide by the power. So that's if you have a constant and you're integrating a constant. This variable here appears next to that constant. Okay, so 3x squared becomes 3x to the cubed over 3, which is x cubed. Negative 2x becomes negative x squared. So we added 1 to the power divided by 2. And 2x, I just explained, becomes 2x. And we need plus c at the end. Don't forget the plus c. Now this is about finding the c. So this is called the general solution. Okay, so how do you think we find the c? Any ideas? So I suppose that's why they gave us the point. Sub in 0, 1 to find plus c. So we have 0, So y is 1, x is 0. What is c? Everyone? 1. So our unique or our specific solution, so this, they sometimes call it the unique or specific solution. Okay, and that's integration. Congratulations.